Hi, everybody. My name is Noah Coakley, a rising junior here at Montreat College, and today I'm going to be giving you my final statistics presentation entitled How Rested Are You? This presentation is actually going to be a study of my Fitbit sleep score that I collected during one semester at college. I really wanted to do is I wanted to determine if my reported sleep score was above or below the average of 83. This average is provided by Fitbit from the users who choose to share their sleep data with Fitbit. So, what is a sleep score? A sleep score is actually a measurement that's between 1 and 100. That's based on a combination of variety of factors, including your heart rate, the time you spend awake or restless, and the amount of time you spend in different sleep stages, such as REM sleep. Typically, a higher sleep score is an indicator of one's restfulness. A person who has a 89 or low 90 sleep score is typically going to feel more rested than a person who has a low 70 to 60 sleep score. During this presentation, I believe that my average Fitbit sleep score will actually fall below the reported average of 83. With this in mind, our H0, our null for this presentation, is going to be 83, and our H1, which is my hypothesis essentially, is going to be that the mean is going to be less than 83. The design of the experiment. This experiment was actually conducted over 63 days, or 63 days of logged Fitbit sleep scores. My motive for this was going to be to determine my average Fitbit sleep score during one semester at college. Since I've started college my freshman year, I have not liked 8 a.m. classes. However, I've had an 8 a.m. class every single semester of college. So it's kind of a love-hate relationship, and I really wanted to just kind of examine that and see how that affects my sleep score throughout one given semester having 8 a.m. at college. Some of the potential drawbacks for this were that some of the days were actually not logged for a variety of reasons. It was charging overnight, I forgot to wear the Fitbit to bed, variety of other reasons. The collecting of the data. So my Fitbit sleep score, as I stated before, is actually collected over a 63-day period. It includes a combination of school days and weekends as well, and the scores range from 63 to 89. This is collected using a random sampling of all the sleep scores since the beginning of the fall 2020 semester when I conducted this experiment. And a few potential issues, as I stated before, were a few days were actually missed because it was charging or I forgot to wear it, woken up from my sleep, or a variety of other reasons. The Fitbit sleep data for the mean of 83, this is actually collected from Fitbit on their website. Some potential issues with this is there is actually no exact mean given. They provide an upper limit and a lower limit. So when I designed this experiment, I decided to use the upper limit when I was designing this experiment. Another potential issue is actually Fitbit sleep scores are actually not collected and shared by default. It actually has to be the user who agrees to share the data with Fitbit for their study purposes. So a lot of people, for privacy concerns or other reasons, choose to actually not share that data. So the descriptive statistics of this, the mean is actually be 81.1. We can round that down to 81 just to deal with whole numbers in this instance, because Fitbit does not provide, or Fitbit provides whole number sleep scores. The median was 82, and the most often was 81. And you'll see this here in a minute, but the majority of the data is going to lie in the lower 80s to mid 80s within this data set. The standard deviation is actually 5.3, and the range was 26 for this data set. My sleep score raw data, these, as I stated before too, these data actually range from 63 to 89, and you can see here the majority of this data lies really within the lower to middle 80s within the sleep score data. So this is pretty typical. The reported Fitbit sleep score from Fitbit is actually going to be 83, so this kind of looks like it may be falling around in that area. And then we have this sleep score right here, 63, which is actually an outlier. You'll see that here in a minute as well. And I must have had a stats test that day because that is my only outlier. My group data and histogram, this is actually going to be conducted with the whole class numbers. So as you can tell here, they range from 63 to 67 with a frequency of 1, 68 to 72 with a frequency of 4, 73 to 77 with a frequency of 8, 78 to 82 with a frequency of 21, and 83 to 87 with a frequency of 24. And finally, the smallest class, which is 88 to 89 with a frequency of 5. With this in mind, we can actually see that we have a left skewed data set. This can be seen whenever we put the data into a histogram form. You can see the majority of the data here falls over here into the right side of the histogram, which is an indication of a left skewed data set. Our measures of position within this study include a 5-number summary, with the minimum being 63, Q1 being 78, Q2 being 82, Q3 being 85, and the maximum being 89. We also have an IQR7, which is Q3 minus Q1, with our only outlier being 63. So the lower fence of this is going to be 67.5. That is conducted by doing the Q1 right here minus the 1.5 times your IQR. So this is really the cutoff for that we have for our data set in determining outliers. Anything less than that 67.5 is going to be considered an outlier, and anything greater than 95.5 is also going to be considered an outlier. So this is actually the box plot that we have for our data set. We have our outlier of 63 right here, as well as our lower, our Q1, which is, I'm sorry, not our Q1. This is actually our lowest data set. That is not including the 63. We also have 78, which is Q1, 82, which is the Q2, 85, which is going to be Q3, and 89, which is our maximum value. This is actually the data with our respective z-scores. So we can see here we also have our outlier, which is 3.4, as a z-score of 3.4. We also almost have an outlier right here, 68. If you recall back, actually our cutoff was 67.5, so anything less than 67.5 was actually going to be considered an outlier. So that's a little bit closer, but the majority of the other data here doesn't fall close to the upper or lower fences. Our estimation and confidence interval. So we can see here we also have our mean of 81.19. We can, as I stated before, we can round this down to 81 just for simplicity's sakes. Our confidence level within this is going to be at a 95% confidence level at 1.3, and our lower limit is to be 79, and our upper limit is to be 82. So with this in mind, we can say that really the true mean sleep score should fall between 80 and 83 with a 95% confidence. During our hypothesis testing, we had a t-stat of negative 2.7, as well as a critical one-tail t of 1.6. Our H0 was 83, as I stated before. Our H1 is going to be less than 83. So since p, which is 0.004, is less than a, which is 0.05, we can actually reject the null for the hypothesis, which asserts the mean sleep score is 83. So therefore, there's actually not enough evidence to support the claim that my Fitbit sleep score would be less than 80. There is enough evidence to support that my claim that my Fitbit sleep score will be less than 83. Some potential issues with this, as I stated before, was data was actually entered incorrectly into Excel. Um, the true mean is actually not reported by Fitbit, so we use the upper and lower limits provided by Fitbit for testing. The accuracy of sleep cycle times is kind of questionable. There's some studies going into that. Also, some factors that affected my sleep, including staying up late to study for a test or woken from sleep, among others. So, conclusion is on average, my Fitbit sleep score will fall below the reported average of 83 on any given day. Although this project was challenging to orchestrate and create, I thoroughly enjoyed the resulting presentation. And if an opportunity presented itself to repeat the experiment, I would want to find other willing participants so we can actually compare multiple sets of data. Thank you for your time.